So you need to learn at least one other scripting language to make yourself more productive, be that Perl or Python or PHP or Ruby or whatever. So I'll talk a bit more about the tools that I think you need to learn. And I've picked, there are many, many tools that a systems programmer uses, lots of tools. And you tend to build your own toolbox over time. I have another talk I give called A Tour of My Junk Code Directory. My junk code directory is a collection of all the little tools that I have written over the years. There's now several hundred of them in my directory. If anyone's interested, that's available at junkcode.samba.org. And there's all sorts of interesting things there, something for everyone. So you tend to develop your own tools over time, and I'd encourage you to publish them, to put them and make them available. But these are the sort of the essential core tools, and I didn't write any of these. I wish I had written some of them, but I didn't. And I thought I'd show you some of these tools and why they're important. Now, those of you that already know systems programming, excuse me if this is a bit boring for you, but some of you may not know about these tools. How many of you have used strace before? Not too many. So okay, this hopefully will be new. So you've probably seen occasionally a command like ls. Yes? You've seen that command. Right. So how does it work? So let's go into a test directory and let's do something like, so we're up there now. Can everyone see that clearly enough? Yes. Yeah? Okay, so we've now got one file called foo there. Now, how does ls work? It works, obviously. How does it work? What does it do? What operations does it need to do?
Trace it, who cares?
Yes. But you can tell me, what basic operations will we be looking for?
Open the directory.
Yeah, open the directory, yes.
Basically, and then do a read date call.
Yes.
Or something.
Right.
Do stat calls.
Right.
Stat or fstat, whatever.
Yeah, okay. So let's have a look at what it does. Okay, so we can strace ls, right, like this. Lots of calls. Now let's have a look at what some of those calls are. All right, so these are all of the system calls that ls is making in order to run. And understanding these calls, understanding how basic programs work, is the first step to becoming a systems programmer. Because these are the system calls that are being made, except all these calls have the first letter chopped off. And if I move the window over slightly, it might be slightly easier to... Bit better? Yeah, slightly better. Okay, so we can see things like exec VE of bin ls. So it's executing bin ls with certain arguments. The first argument, the name of the program, is ls. We can see things like uname. So it's asking the operating system for identification information about the system.
Would this be ls doing it, or is this tracing the...
This is actually, yeah, tracing the... no, it's after the exec. So the exec has started, so this is actually... This would be in the loader. I think. Yeah, ld.so, which is linked into ls. Yeah, so I'm saying making it all part of ls proper. The main program doesn't start till where? Down probably around here. No, but I think it actually starts a little bit up. It's allocating some memory. Enoch dev null. Interesting. There's a bug. Well, we can see that. Look at this. Look at this. Look at this system call here. It's doing an open of dev null, and it's passing a flag to say open it as a directory. Why? Why would it be opening dev null as a directory? You can never open dev null. Dev null is, you know what dev null is? The bit bucket. It's where you throw bad code and PHP scripts. And so why would one be opening it as a directory? Some programs open dev null because they're allocating memory. And what they do is they use a virtual memory trick where they mmap dev null or dev zero. And they actually use that to allocate memory. It's a strange trick. You need to read up about virtual memories to understand why they're doing that. But this is pointless. And it seems completely pointless for it to do that. And that's probably a bug. How would we narrow down the bug? We could look at the source code. I prefer not to look at the source code. It's more interesting to find out in other ways. Let's L trace it, and what we'll do is we'll do an L trace. Now L trace shows library calls, and what we'll do is let's wander down to the dev null. There's the open of dev null sysopen. Aha. Okay, we can see what's happening here. This is ltrace is another systems programming tool. It traces library calls. Right? So system calls are the calls going from user space into the kernel. Right? And you need to understand those to be a systems programmer. But most systems programming works above the C library at least. The C library is the friendly, sometimes, interface between the operating system and most applications, right? And really every system has got a C library. And the C library on Linux is called glibc, maintained by Ulrich Drepper, who's another one of those people that can be hard to get on with occasionally. I've had a few run-ins with Ulrich. Now, what we're seeing here is that the ls command is doing an opendir on dot, and this hasn't finished. But within that opendir, so it's opening the directory dot, it's doing a sysopen of dev null. So that open of dev null is inside the opendir function inside the C library. So we have found a C library bug. All right, we need to tell Ulrich. Okay, that is a bug in the C library. It's doing a pointless operation, completely pointless. And then we can see the opendir resumes, and the opendir is succeeded. So the application has no indication as to why, as to the fact that this error has happened. There was an ls ran perfectly, but it's still doing this pointless operation, completely pointless. Yes? Where we can see what other operations it's doing. Inside opendir, it first of all tries to open dev null. I'm guessing that it's probably a badly coded attempt at a memory allocator, and then it's falling back to a break-based memory allocator, but we have to look at the code to understand that. Then it's finally doing a sysopen of dot, so it really is opening the directory. And these flags, unfortunately, ltrace isn't interpreting these flags. So we would have to look up these flags in the include files in user include, systat.h probably, or async.h, something like that. And then we can see that it's opening the directory. And why this number here? Why that third argument to open? That's a very strange number, isn't it? Very strange number. I'll show you another tool while I'm here. All right? This is my chance to show you a piece of my junk code. And let's see. Nice big font up here. I've got this program called I that everyone should have. All right? And I is a program that displays numbers in different formats. So it displays it in binary and in hex and in decimal, right? And you can pass it in, you can see whether it's decimal or hex or whatever, and it will then reformat it in different formats. Very useful, very, very useful. And so sometimes by displaying it in a different base, it then becomes obvious what it is, because it's not obvious in one base, it's obvious in another. It looks like garbage in all bases. It's garbage in all bases. So what is it? Come on, you're not thinking. What's the third argument to open?
That's why you're manly.
Ah, no. You need to know some of the basic calls. Open is a basic enough call that you need to know it, not look in the man page. Come on, who knows the third argument to open? No, second argument. Right. The third argument is the mode. It's a mode T, but open is a strange function. It's a varargs function. So it only takes the third argument if the second argument has an ocreat bit set. If ocreat is not set, the third argument is ignored. ltrace doesn't know that. ltrace is displaying a garbage argument. It's random. It's whatever happened to be on the stack. Because the program is only passing to